Now, let's go through our first related race problem step by step. This example will show you the full process, and this is the structure you use for almost every problem in this section. First, let's try to understand the problem. We're told a spherical snowball is melting in such a way that its radius is decreasing at a rate of 0.4 centimeters per minute. At what rate is the volume of the snowball is decreasing when the radius is 14 centimeters? So let's pause and think. What is changing? What are we given? And what are we trying to find? Let's take a look at this picture. This is a sphere, and this is the radius. When the snowball is melting, it's getting smaller and smaller. So the radius is also getting smaller over time. And since the volume depends on the radius, if the radius changes, the volume will change too. So those are the two quantities we are going to focus on. Now, let's define our variables. Let R be the radius and V be the volume. Both of these are changing over time. Now, let's write what we know. Go back to the problem here. We are told the radius is decreasing at the rate of 0.4 centimeters per minute. This is the rate of change of the radius. So we're given dr over dt. The negative sign is important because the radius is decreasing. So when the rate is decreasing, it's negative. When the rate is increasing, it's positive. Now, what are we trying to find? We are asked at what rate the volume of the snowball is decreasing. We're looking for the rate of change of the volume. So we're looking for dV over dt. Next, we need an equation that relates both volume and radius. Since this is a sphere, we will use the volume formula of a sphere. The volume formula of a sphere is V equals 4 over 3 times pi times r to the third power. In this equation, V is the volume, which depends on time, and r is the radius, which also depends on time. 4 over 3 and pi are just constants. Now, we need to take the derivative of both sides with respect to time. The derivative of the volume with respect to time is dV over dt. To differentiate the right side, we will leave the constant in the front and we'll differentiate r to the third. To find the derivative of r to the third, we'll use the chain rule. The outer function is the power function. So we have 3 times r squared and multiplying by the derivative of the inner function, which is the derivative of r. So this is the derivative of r to the third. We have 3r squared times the derivative of r, and the derivative of r is dr over dt. 4 over 3 times 3 is 4. So I will have 4 pi r squared multiplying by dr over dt. After differentiating both sides of the equation, I'm now ready to plug in numbers. I plug in negative zero point 0.4 for dr over dt and 14 for r. 14 squared is 196, and 196 times negative zero point 0.4 times 4 is negative 313.6. So the rate of change of the volume is negative 313.6 pi. This is the rate of change in exact answer. If the question does not mention about approximation, that means they want exact answer. So you leave the answer like this. If the question asks for approximation, then you should turn this into decimal and follow the rounding instruction. For example, the approximation of this is negative 985.20. Since this question does not ask me to approximate, so I will use the exact answer, negative 313.6 pi. Now, let's interpret this. The volume of the snowball is decreasing at the rate of 313.6 pi cubic centimeters per minute. The negative sign tells us the volume is decreasing.